So this video is integrated one, chapter 2, D-Day number 1. This is the D-Day that was Monday, October 11th. So we have a table here, and for this, we're dealing with a new sister, and we're trying to track her growth, okay? And we say that the growth is constant, so that means that it's going to be the same every time. So I'm looking here. From here to here, my change of y is 4. From here to here, my change of y is 4, where y is the height. From here to here, my change of x is 2, and that's months. So basically, what's happening, change of y over change of x, if I'm looking, and you always want to look over the same set of points. So if I'm looking this point and this point, the change of x is 2, the change of y is 4. So that is going to be 4 centimeters every 2 months. Or as a unit rate, 2 centimeters every 1 month. Okay. And so now let's answer some of the questions and fill in the, I'm just going to put M for month. So if I continue going backwards, 72 minus 4 would be 68. Minus 4, that would be 64. Minus 4, I get 60. So at birth, she was 60 centimeters. And then I'm going to go by 2's going backwards. So 6, 4, 2, and then birth is 0 months. So here on the first one, it says complete the table. We complete the table. How tall was Mariella at birth? She was 60 centimeters tall. How many centimeters does she grow every 2 months? So 4 centimeters every 2 months. I just want to emphasize that 2 months. Write an equation representing her growth. So the equation is going to be y equal. And we can start with the 60. She's starting at 60 centimeters and she's growing not 4, not 4x, it's 4 every 2. So 4 every 2, again, is really just 2. So this is going to be 2x. That's your equation. And then we want to predict how tall she'll be at 2 years old. Now, we got to remember, you need to pay attention that the x is age in months, not years. So this is 2 years. We need to convert 2 years into months. So 2 years is equal to 24 months. So I need to put 24 into my equation. So I'm going to go y is equal to 60 plus 2 times 24. So that is going to be 60 plus 48. That's going to be 108 centimeters. Okay. On the next problem, we have this graph here. So this graph is figure number on the x and number of tiles on the y, and this is decreasing. So our y-intercept is 0, 8, this point right here. And what does this mean? This means that figure 0 has 8 tiles. That's what it represents in this problem. What is the slope? Now for this, they drew it. I don't like the way they drew it. They're saying we're going 1 every 2. I prefer to go like this. So we're going to go down 2 every 1. Okay. So our slope is going to be -2 over 1 or just -2. Now, what does that represent in this problem? Each figure number decreases by 2 tiles. Okay, so each time I increase my figure number, the tiles decrease by 2. Unit rate. So unit rate, we look at the slope, and the unit rate was -2 tiles every 1 figure number. And that would be our unit rate. Okay, we're losing 2 tiles every figure number because we want it per 1. So this is per 1 figure number. Okay, on the next problem, find the equation of the line given the following. So remember, equation of the line is y equal mx plus b. So I know my slope, so I know it's going to be y equals 2/3 x plus b. And then I'm going to put this 30 comma 45 in for my x and y. So I am going to have 45 is equal to 2/3 times my x, which is 30, plus b. And I'm going to put my 30 over 1. So when I'm dealing with this right here, I can go 2 times 30 is 60 over 3. And 60 over 3 is 20. Or what I might notice is, hey, 3 here can go into 30 here 10 times. 2 times 10 is 20 plus b equals 45. Either way, I got 20. I'm going to minus 20 from both sides, so I'm going to get 25 is equal to b. So then my final equation is y is equal to 2/3 x plus 25. Now on b, I'm going to use the same y equal mx plus b, but I need to find my slope first. So slope is change of y over change of x. So my y's are 3 and 5. So that's going to be what I'm using for my change of y. So I can either do 3 minus 5 or 5 minus 3. Let's say I do 5 minus 3. So if I do 5 minus 3, 5 is from this one. Then I need to do 6 minus 7. I got to keep that order. So I'm going to get 2 over -1 or a -2. So at this point, I've got y is equal to -2x plus b. And I'm going to use one or the other point. Let's say I use my 7, 3. Doesn't matter. Use one of the 2 points. And we're going to put it in for the y and for the x. Okay. So I am going to have 3 for my y is equal to -2 times 7 for my x plus b. So 3 is equal to -14 plus b. I'm going to add 14 to both sides, and I get 17 is equal to b. So my equation, y is equal to -2x plus 17. That's our equation. Okay. Next section is all exponents problems. So on this, when I'm trying to deal with this problem, you can think of this as 2x times 2x times 2x. 2 times 2 is 4, times 2 is 8. X times x times x is x to the third. That's one way to think about it. Another way to think about it is both the 2 and the x are being raised to the third power. So my 2 is being raised to the third power, and my x is being raised to the third power. 2 to the third is 8, x to the third. So in both cases, I got the same answer. On the next one, again, you can think of this as 3xy to the fourth times 3xy to the fourth. You can expand it. 3 times 3 is 9. X times x is x squared. And y to the fourth times y to the fourth, I add those exponents, I get y to the eighth. That's one way to go about doing this problem. Another way is like the last problem. My 3 is being squared, my x is being squared, and my y to the fourth is being squared. 3 to the squared is 9, x squared. And then here, when I have a y to the fourth to the power 2, I call it power to power, we multiply. So the exponents 4 times 2 becomes an 8. And you see I got the same answer as when I expanded it. So do it whichever way you understand best. Okay, next one. We don't like negative exponents. So if you have a negative exponent, that y to the negative third is my problem. So I am going to take that and I am going to move it up. Okay. So whatever's negative in the denominator for an exponent, when I move it, it's going to become positive. My 4, I'm fine with right now. My x to the fifth, I'm fine with. My y to the second, I'll deal with all of those later. My 2 and my x, neither one of those are being affected by that y to the negative 3. But I'm going to move the y to the negative 3 up. So now it's up here. Okay. And now I'm going to clean this up. So 4 divided by 2 is 2. Now, when I have x to the fifth on top and a x on the bottom, I have one x I can take from top and bottom. And so I am going to be left with x to the fourth. And then I have my y squared. Let me just get rid of this for a second. I've got my y squared times my y to the third. When I multiply bases, I add the exponents. So this is going to be y to the fifth. And that's my answer. 2x to the fourth, y to the fifth. So on this one, it says, Ms. Kolar thinks the answer to the following problem is no solution. Is she right or wrong? Explain your reasoning. Okay, so you can do this a couple of ways. You could distribute and get 2x plus 6. So distributing the 2 to each of these is equal to 6 minus 6 from both sides. And we get 2x is equal to 0. Divide both sides by 2. And 0 divided by 2 is 0, not undefined. So she's wrong. Answer is 0. Another way to have done that same problem is I could have divided this side by 2 and this side by 2. And that will have those 2's cancel out. And I'm going to be left with x plus 3 is equal to 3. I'm going to minus 3 from both sides, and I get x equals 0. So is she correct? No. The answer is 0, not no solution. No solution would be if I was dividing by 0. Okay, if I had 0 on bottom, that would have been no solution. Okay, on these problems here, I'm going to kind of color code things. So they want us to identify what's happening with these things. So first thing I want to do, I'm just going to darken in. This is our y-axis. This is our x-axis. Okay. So I'm going to kind of color code things. I've got this orange line that crosses here. I have this pink line that also crosses here. Okay, so both the orange and the pink have a positive y-intercept. So that means they either have to be 1 or 4. Okay, that's the ones that they have to be, either 1 or, Roman numeral 2 or 4, because those ones have a positive y-intercept. The other two have a negative y-intercept. Now, in both of these cases, my orange one's increasing. My pink one is decreasing. So my orange one is going to be going with number 4. So this is going to be A. Why? Because it has a positive y-intercept. And that positive y-intercept is a 2. Okay. And a positive slope. My 1/3. So that is the only line that has a positive y-intercept and a positive slope. So B is going to be this one here. Why? It has let me give myself more space here. It has a positive y-intercept. And that y-intercept again is 2. And a negative slope. Okay, it's decreasing. So it has a negative slope. And in this case, that negative slope is -2. So now the other two have to be Roman numeral 1 and 2. So if I'm looking at this blue one here versus this, let's say, purple one here, both of them have a negative y-intercept, and both of these have negative y-intercepts. One of them steeper than the other. The purple one is steeper than the blue one. So the steeper the slope, the bigger the number. So the purple one is going to go with this one. So this is going to be C. And again, Y has a negative y-intercept of -2 and a steeper slope to compared to the other one. So the bigger the number for your slope, the steeper it is. So that means that this one here has to be D, and again has a negative y-intercept. Okay, and this y-intercept here in our equation is -2, and a less steep slope, and 1 is less steep than 2. So that's what you want to think about explaining when you do these problems. So again, when you're looking at these lines, you want to focus on where they cross the y-intercept. So here, this is, here, this is in the positive y's. So you want to look and see which one has positive y's. And again, that is your +2, +2. So those have to be the ones that go with that pink and the orange. Again, the pink is decreasing, so that means you have a negative slope. That's why I chose Roman numeral 2. My orange one is increasing, and that's why I chose Roman numeral 4. Then when I'm looking at the y-intercept here, this has a negative y-intercept. So I'm looking at the -2, -2. Both of them are positive. So how do I know which one's which? The steeper the slope, which the purple one is steeper, the bigger the slope number. The slope number has to be a bigger number, has to be a greater number. So the 2 is greater than really this x, which is a 1. So the purple one has to be the one with the 2, x -2, and then the blue one has to be the one with just plain old x -2. Okay, on these function machines. Okay, so on this one, they're giving us an input. So I want to figure out if I put in a -3, what do I get out? So I get a -15 plus 3, which is a -12. On B, this time they are giving us the output. Okay, this was the input. This is the output. So I know I should be getting out a 6. So I'm going to take the 2x minus 5 and I'm literally going to set it equal to 6 and solve. So I'm going to add 5 to both sides. I'm going to have 2x is equal to 11. I'm going to divide both sides by 2 and I get x is equal to 11 halves. Or if I put it in my calculator, 5.5. Okay, all of these are solving for y. So what I would do first is if I'm trying to solve this, I like to deal with my y's first. So I'm going to subtract 3y from both sides, or my x, whatever letter. In this case, I'm dealing with y. So I'm going to get 3 is equal to 4 plus 2y. Then I want to get my 2y by itself. So I am going to minus 4 from both sides. And when I do, I get -1 is equal to 2y. And then I divide by 2, and I get -1/2 is equal to y. And that's your answer. Now on B, we have a lot of stuff here we have to deal with. I personally would distribute this 3 first. Do not take the 8 plus 3 and get 11. That's no. No, 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 no. So I'm going to distribute my 3. I get a 3y. 3 times a -1 is a -3. It has to multiply with both the y and the -1 equals 5 plus 3y. Then what I would do is I'm going to look on this side and go, hey, can I clean up things on this side? The other side, I have a 5 and a 3y. Those aren't like things. But on this one, I can clean it up. And I am going to get a 5. Whoops, still on highlight. Sorry. I'm going to get a 5 when I take my 8 and my -3 plus 3y. Now, some of us might recognize, hey, it's the same on both sides. So that means the answer is going to be all real numbers. Some of us may not recognize that right away. So if you're not recognizing it, that's fine. But what I would recommend doing, always get rid of your y's first, and not get rid of, but deal with your y's first. So I'm going to subtract 3y from both sides. And when I do, I get 5 equal 5, which is a true statement. And so when you end up with your variable disappearing and you get a true statement, your answer is all real numbers. Then I'm going to look at letter C. We're solving for y. So that means I want to get this plus 3y by itself. So in order to do that, what I would recommend doing, and here I'm going to make this a little more transparent. I don't like it being so dark. Okay, then what I'm going to do is I'm going to minus 2x, and I am going to get 3y is equal to, and on the other side of the equal, I get a 12 minus 2x. I can't combine them. They're not like things. Then I'm going to divide by 3, and I can divide the whole side by 3, but I think I'm going to divide them each separately by 3. And I'm going to get y is equal to 12 divided by 3 is 4 minus 2/3 x. Then I have it in the nice form of a line. I can identify my slope as -2/3 and my y-intercept as 4. Okay, so for this one, we want domain, range, and then we have some other questions. Okay, so for this, I'm going to get myself a line. I'm going to make it kind of transparent so I can somewhat see through it. Okay, so let me just draw. I'm going to hold shift and draw a vertical line. Let me get a different color and draw a horizontal line. Okay. And then I'm just going to come and move these. Okay, so when I'm talking about domain are your x's. Okay, your x's. And so your x's, if I drag this green one across, I want to ask myself, let me zoom in. What is the furthest to the left this graph goes? Well, the furthest to the left this graph goes is right here at -3, but it's open circle. So it's not including -3. It goes almost to -3, but then it doesn't quite get -3. And then here it's going to keep going until I get to 6. And again, it's an open circle. So 6 is not included, but it goes all the way up till you get to 6. So my domain, because it goes from -3 but doesn't include -3, I do an open bracket as opposed to a closed bracket. Closed bracket would have been if that had been a solid dot, and it's not a solid dot. So I have a parenthesis, which is an open bracket, to 6, which is also an open bracket. Okay, then when I'm looking at my range, and my range are my y's. Okay, my range. So let me get this line. And I want to think what's the lowest to highest. So as I move this down, the lowest my graph goes is -1, but again, it's an open dot. So it's not going to include -1. And as I go up, the highest it's going to go to is 5, but again, it's not going to include 5. So it's going to be an open dot. So again, -1, but not including it, to 5, but not including it. So this is going to be open bracket, -1 to 5, open bracket. And then when I want f of 3 basically means my x equals 3, what is my y? So really it's kind of asking us 3 comma what? So in order to find that, what I'm going to do is I'm going to look at my vertical line here, okay, my green one, and I'm going to go to where x is 3. This is where x is 3, up and down this line. And where does that line cross the graph? Right here. That is 3 comma 1. So what does f of 3 equal? F of 3 equals 1. That is your answer. Your y is 1 when your x is 3. Now, when I'm looking at this one here, this time I want to know what is my x when my output or y is 0. So I know my y is 0. So I'm going to come back to this graph, and instead of looking at this vertical line, I'm going to look at my horizontal line. I'm going to move this horizontal line until I'm where my y is 0. This is where my y is 0. Okay, on the on the x-axis. And where does that cross? Well, it looks like about here. So it looks like it's a little more than 4.5. So let's say 4.6 would be reasonable. So x is equal to 4.6. Now, the next part is the little race. So first thing I need to look at is I'm going to label this. So this is going to be my x-axis, okay? This is going to be my y-axis. And my y-axis and x-axis have to be in particular. This is going to be seconds. This is going to be meters. And then I'm going to label 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's going to be 10. 1, 2, 3, 4, 5. So I get up to 15. I'm just going to move the seconds over a little bit so I can write my 15 here. Okay, so 1, 2, 3, 4, 5. Whoops, still an eraser. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my race, they said, is 10 meters long. So this is going to be the finish line. So Zoe got a 2-meter head start. And rode her tricycle 4 meters every 3 seconds. Okay, so I'm going to do Zoe in purple here. Okay, so Zoe got a 2-meter head start. Okay, let me, I'm going to actually find my mouse here. Make this maybe into size 6. Okay, she got a 2-meter head start and did 1, 2, okay, 1, 2, 3, 4 every 1, 2, 3. 1, 2, 3, 4, every 1, 2, 3. And I'm going to draw my line. And that is going to be, oops, Zoe. And for Carlos, I will do him in blue. And so for him, he's going to start at 5 because this equation is y equal 1/3 x plus 5. So he's going to start at 5. And then his speed is really going to be 1 meter every 3 seconds. So they met right here. 1 meter every 3 seconds. 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 And I'm going to draw my line. Hold on. My mouse wasn't working here. Let me try it one more time. Draw my line. Okay, and I'm going to put C for Carlos. Okay. Then we have Andrew. I'll do Andrew in, let's say, red. Okay, so this is going to be Andrew. So Andrew had a 1 meter. Andrew is 1 meter into the race after 5 seconds. So he's 1 meter into the race at 5 seconds. So I got to go to 5 seconds and then he's 1 meter right there. Okay, be careful. Don't go 1,5. It's 1 meter. So this is meters and 5 seconds. And then 9 meters into the race, 9 meters into the race after 10 seconds. So right here. And then I'm going to connect these. Okay, and that is Andrew. So it says, who wins the race? So the one who wins the race is this person right here, which is Zoe, because Zoe had the fastest time of 6 seconds. 6 seconds was her time. So Zoe oops, didn't want it that color. I was going to do this one. So Zoe, I don't need the highlight. So Zoe won the race with the fastest time of 6 seconds. When does Zoe catch Carlos? So Zoe is my purple, Carlos is my blue. That happened right here, and that is 3 seconds, comma 6 meters, but they want to know when. So that's going to be 3 seconds. So Zoe caught Carlos at 3 seconds. After 5 seconds, who was first, second, and third? So for that, I'm going to go to 5 seconds. Okay, let me get rid of this right here. And I'm going to draw a line at 5 seconds. I will draw it in this baby blue here. Okay, so 5 seconds. This is 5 seconds. So I'm going to draw a line at 5 seconds. This is representing 5 seconds right here. And so I want to go from the starting line, okay, and then I can number people. So This person right here, whoops, this person right here, which is Zoe, is first, then second is Carlos, then third is Andrew. So we want to go backwards. We want to see who's closest to the finish line. So we want to see who's closest to that green y = 10. So let me write that out. So first is Zoe. Second is Carlos. And third is Andrew. And this is when we're talking after 5 seconds. So we're talking about looking at 5 seconds. When does Carlos finish the race? So Carlos finishes the race over here at 15 seconds. So Carlos finished the race in 15 seconds. And that's the end of this video.